In today's tutorial, we will discuss with you about the paper chromatography. And we will start our discussion from the introduction of the paper chromatography. Well, before I start my discussion, I would love to mention that in today's tutorial, we will learn about the introduction of the paper chromatography, a short kind of introduction of the chromatography also, and after that we will know about the main components of any type of the chromatography. And after that, we will talk about the main components of this paper chromatography. And we'll further continue our discussion with the instrumentation or the materials required to perform this paper chromatography. After that, we will know about the working. You can call it as the procedure of the paper chromatography. And we will also know about the principle, the analysis, and the types of the paper chromatography. So these are actually the points that we will discuss in today's lecture. So let's start from the very first point, the introduction of the paper chromatography. Paper chromatography is actually a planar chromatography. Why is it called a planar chromatography? Because it is performed on a plane surface. The paper chromatography is actually performed on a plane surface. That's why it is also called as planar chromatography. Also called as planar chromatography. Now we have actually two types of plane. One plane is a paper, which is also a plane surface, and another one is a slide, which may be of the glass or a plastic. Okay, so we do have now two types of plane surfaces. If we are using the slide, then that type of chromatography will be named as TLC, thin layer chromatography, which we have already discussed. And if we are using a plane surface like a paper, then that type of the chromatography will be known as paper chromatography. Now here we got the concept that why the paper chromatography is called as paper chromatography, because we are using the paper. That's why it is called as paper chromatography. Now another very important point is that these two plane surfaces are actually also known as the bed for the stationary phase or the supporting medium for the stationary phase. So in short, these two surfaces or planes are actually helping in support of the stationary phase. We actually put our stationary phase on these two surfaces. Now let's come towards the next point, that is the chromatography. Now what is chromatography? It is actually a separation technique in which we separate the mixture. So if you want to know the components of the particular mixture, so we have to separate that then. Now if we are using any technique by which we are separating the mixture into its components, that technique is actually known as chromatography. So in one line you can say it is actually a separation technique. Now the next point is that what are the main components of any type of chromatography? We do have different types of the chromatography. Now what are the main components that are actually present in every type? Those two main components are the stationary phase and the mobile phase. Now what is stationary phase? Stationary phase is meant by the phase which is actually standing, stagnant, or fixed, you can say. If any phase is fixed, that is called as stationary phase. So the phase which is fixed in the chromatography, that is known as fixed phase, stationary phase. And the one that is moving or mobile, that is called as mobile phase. So mobile stands for moving. Okay, so we have a fixed phase and a mobile phase that is actually moving on the stationary phase. So mobile phase is the one which is moving and stationary phase is the one that is fixed. So now let's come to the next point, that is what are the main components of our paper chromatography. The point is obvious that in every chromatography we have these two components. So we do have the same two components in the same chromatography, in the paper chromatography. Now the very difference lies is that in every chromatography we have different types of the stationary phases and mobile phase. So in this particular paper chromatography, our stationary phase is alpha cellulose, which is a paper having moisture. So this stationary phase is actually a liquid phase, which is present on a paper, So you can use another paper also, which might not be having the moisture. Then that will be considered as the solid stationary phase. So here I am giving you example of the liquid stationary phase, which is alpha cellulose, a paper having moisture on its surface. The next one is mobile phase, which is actually maybe a solvent or it may be a mixture of solvent. You can use any. So now in this particular technique in the paper chromatography, the one that I am telling you people right now is the liquid chromatography. Why? Because our stationary phase is liquid and our mobile phase is also liquid. So you can also call it as liquid-liquid chromatography. Now this chromatography is going to be performed on a paper, so you can call it as paper chromatography, and paper is a plane surface, that's why it can also be called as planar chromatography. I hope it makes sense. Now the next point is the instrumentation or the material required to perform this HPLC. What we need a paper. So in our this chromatography we need a special type of the paper, that is the alpha cellulose, which is having the moisture. Now these dots are actually representing the moisture present on this particular paper. What next we need is that we need a pencil and we need a sample. Along with that we need our mobile phase, the solvent. So what we need? Paper, pencil, sample, mobile phase, and stationary phase is actually in the paper, which is the drops, which is the moisture on the paper. And now the next point is the working, how these instruments actually work. First of all, we will take a paper, and now we have got this paper. You will just take this paper and you will consider one side as a base side, and after the consideration you will just sketch a line on one side. Suppose I considered this side as a baseline, and here by means of the pencil, not by the pen. You know, the ink present in the pen is also a kind of mixture, so if you use that pen, the ink of that pen will then interrupt our this chromatography, so we must avoid using the pen. So here we are using pencil to sketch the line. Now here we have a very important point is that when you select the side for the baseline, you must consider that this line must be sketched 1 to 2 centimeter a little bit above from the base edge. Well, nowadays in most of the practicals, or you can say in most of the practical performances, this line is sketched 1 centimeter above from the base. So consider this as 1 centimeter above the base edge. Now this is the base edge and this is the baseline that we actually now sketched by means of the pencil. So in some other practicals and in some other text is mentioned that you can sketch this line up to 2 centimeters. 1, 1.5 or 2, you can sketch any. Well, in most of the cases it is observed that this line is actually 1 centimeter above from this particular base edge. Now this is our baseline. On this baseline, what we will do next is that we will spot our sample. Spotting of the sample will be done in the fourth step. Now how will you spot the sample? You will take your sample by means of the capillary tube, and then you will spot that by a very careful manner on this particular line. And after you spot the sample, you will just leave your this particular stationary phase, which is actually a spotted stationary phase, aside to become dry. And in the meanwhile you will be having a chamber in which the mobile phase or the solvent will be available, and this must be closed, packed. Okay, the reason behind is that we need to perform our practical in a saturated atmosphere. So for that we need to pack our this particular chamber. So then how will our this chamber become saturated? You know, our solvent, or you can say a solution which is present here, will evaporate and then it will be dispersed in the entire chamber. So like this chamber is then called as saturated chamber. Now what will you do next is that you will take your particular this spotted stationary phase and you will just hang that stationary phase in your this saturated chamber. And one very important thing is that you must take care of that your this particular baseline on which you have spotted the sample must not be dipped in the solvent. If it is dipped, then it will dissolve in the solvent. Then your chromatography will become fail, you can say. Then your chromatography will be of no use. So you must dip it in a fashion that your this particular baseline must be above the solvent. So this is our baseline. And what next you are supposed to do is that you will leave the entire instrument for a while, and after that you will observe that your sample is separated into components. Suppose we have 3 components in our this particular sample number 1, number 2, number 3. Like this, they will be separated by means of this particular mobile phase, or you can say solvent, which has been moved on this particular stationary phase. So this is the region after which our stationary mobile phase has moved, and these are the specific or particular regions that have been covered or moved by our components present in the particular sample or mixture, you can say, which we are about to separate now in this particular technique. So this is the next step, the 7th step. In this, what will we do? We will just take our this stationary phase out, and we will then find the RF. Now this is the very point which is going to tell us more about our this particular sample. How, like, RF is known as retardation factor or retention factor. Now this is a type of calculation. So by means of this, we will just measure the distance moved by the solute or the component which are present in our mixture, and we will divide that by the distance moved or traveled by our solvent, or you can use another name for solvent as solvent front. How? Like, this is the formula, RF is equal to 1 by F. Now I told you that we are having just 3 components. Now I just considered this particular separation, okay? Number 1, number 2, number 3. So now from the baseline, this is our baseline. From the baseline, component number 1 has moved this particular distance, and number 2 has moved this distance, and number 3 has moved this particular distance. And our solvent front, which is the next name for the mobile phase or for the solvent, which has moved this particular distance from the baseline up to this particular region. What will you do if you are going to find the RF for any component? So we can find separately for all the components. How? Like, suppose if I want to find the RF for the very first component, I will write the RF, then I will write the distance moved by the RF from the baseline till this particular portion up to which our first component has moved. This distance I will measure. After the measurement, I will just write here this value of the first component. Then I will divide by the F. What is F? F is my solvent front, the distance moved by the solvent from the baseline up till this particular region. So then like this, I will write these two together here, and I will divide both the values. The top one is representing the value of the distance moved by the first component, and F is representing the value of the distance moved by the solvent front. You will divide these two together. After division, you will get the RF value. Then this RF value, you will match this RF value with the standard value. Now we have actually 2 types of result whenever we are performing any type of practical performance. One is the result that we take or we obtain through our experiment, and one is the result that is already available. That is actually known as the standard result. Now the result which we got through our this particular technique, we will just match our this result with the already available, the standard result. Then it will be easy for us to identify that what type of component is this, or you can say what type of the components are these if we perform the RF for all the components. This is how we separate, and after the separation we know about the components present in our particular sample. Now let's come to the next point, that is principle. Here I have mentioned adsorption and partition. Now these are the 2 principles, but the very one principle is valid for our this chromatography. Now we told you people that our stationary phase is a liquid and our mobile phase is also a liquid. So when there is a liquid mobile phase, liquid stationary phase, so then the sample will separate by interacting with both the phases. So if a sample is interacting with the liquid mobile and liquid stationary phase, liquid mobile phase, liquid stationary phase, then this type of interaction and separation is done by the principle known as partition. When any component is separating into liquid phases, that is actually known as partition. So this one is partition chromatography. Why? Because our stationary phase and mobile phase both are the liquid phases. And in case I told you that we can use a stationary phase other than this alpha cellulose, that might be the solid one. So if we are using the solid stationary phase and liquid mobile phase, then our principle will change. Then what will be the principle? Simple. That will be the adsorption. So in that case, our sample is actually interacting with the liquid mobile phase and solid stationary phase. So if your component is separated by means of a liquid mobile phase and solid stationary phase, this type of separation is actually done by the principle, that is the adsorption. I hope it is clear now. The next point is the analysis. We can do the analysis of different types of the compounds. There may be the color, maybe the non-color. And this is the particular way through which we actually analyze the colored substances. Consider if we have a colorless substance sample, which we are going to analyze. For that, what will we do? We will just wait for a particular time. After waiting, we will just take our this stationary phase out. But those will not be visible to the naked eyes. Then we will just apply a light on that. After that, same procedure is performed as we did for this colored one. So this is how we separate both the colored and the colorless mixtures, and we analyze. So we can do the analysis of different samples and different products. They may be colored, they may be non-colored. So we can do both the types. Well, now we have the types. Regarding the types point of view, we have different types of the paper chromatography. Let me give you example through a particular paper. Here I have the paper. Suppose this is my chamber, and in this chamber I am actually going to dip. This is the baseline on which my sample is available. If it's visible, it's okay. If not, then just concentrate the procedure that I'm going to perform now. We have one type that is called as ascending.